Hello everybody, my name is Jacob and I would like to share today a new Helm plugin which we developed for one of the customers, which is for multi-cloud orchestration, basically for orchestrating Helm charts across multiple Kubernetes clusters. So first couple of slides and then quick demo. The problem what we faced in general with the Helm and with the way how to deploy the application is that to be able to do it, people need to understand couple of things, which is sometimes very difficult. So when you want to start some application which consists of multiple things like Zookeeper, Kafka, Grafana, and you want to reference those components across each other, you basically need to go through a couple of those steps. First, you need to understand those open source components and the Helm release Helm charts, because each Helm chart has different syntax, different notation. Then you need to create the Docker files, build images, push into registry for your specific application. Then you can create charts. Of course, you can use tools like Draft, which will help you with this to boost your Helm. But then, and this is the part what I want to focus today, you need to prepare overrides. And here is the example. This is the script which I had to create to be able have idempotent way how I can install over and over idempotently my application analytics stack. So as you can see, I had to do some parameterization and then through DNS reference charts each other, start them in some order, replace it. So I had to create 6 files and then pass those 6 files to all the files, which is pretty complicated. And therefore, we created very lightweight plugin, open source plugin for multi-cluster orchestration called Apply, which should allow describe entire application stack in the simple way and define inter-application dependencies. So it's like abstraction for container and clusters. So here is the link which you can check. I will put it into video description. And as you can see, you defined Helm charts repository, clusters which you want to use, and then just releases with the reference and dependencies each other, what you will see in my demo. So my demo, I will use multi-cloud analytics stack deployment where I have a Google Kubernetes cluster and Kubernetes cluster running on AWS. And what I will do, I will use simple YAML syntax for this stacks and I will apply it against those clusters. And basically I will deploy TweetPub, which will read information from the Twitter streaming API, send tweets into Kafka using Zookeeper, then process them in the Spark via Spark job, those tweets, store them into HDFS, and then read from HDFS in API, and then most importantly the UI part will run in AWS. So it's one of the use cases what we solve where people want to run analytics data processing in the one cloud provider and then web application in the another provider. And this is what you will see in the demo. So let me jump here. So here what we have. So I have two contexts. I have AWS context with those nodes, and I have GKE where I have just one node. So I have two clusters, and what we will be doing, we will be deploying into demo namespace, so we can check that both are right now empty. And we prepared a simple YAML for Twitter stats which I will be launching. I will describe it later because it takes some time to bootstrap it. So, and if we check the help, we can see that here is the new available command called apply, and we will do helm apply. One more time. We will do helm apply Twitter stats YAML. Yes, so and as you can see, we deploying HDFS, Tweet.api, TweetUI demo release, Zookeeper, so all is happening. And meantime, before all this will happen, I would like to take you through this. So you can see it's pretty fast. In the second tab, we can check what is running in GKE right now, and we can see that it's starting. So Zookeeper is starting, Kafka is starting, AFGFS nodes, Spark nodes, TweetPub, TweetUI. So all those components in AWS, we should see UI part, which is starting. And meantime, let me show you a little bit about our plugin. So this is the YAML. So very simple way, very simple notation. We're using our Mirantis Helm charts because we have standardization for all those open source components. So it's our upstream open source repo with the charts. Then I'm defining clusters, basically namespace, and where I want to deploy an external IP where it will be later reachable, and then releases. So basically chart, cluster, dependency on another chart. So this is how I am building the structure, and wait means that it waits until it's deployed, basically. So this is the very simple syntax notation what we are using. And how works the plugin? So basically together with Helm we using this plugin YAML, and this plugin YAML basically define the name, the version, the usage, description, and then command how it's done. So it's a simple binary which extend the Helm and making available this function. So then in varlib, then in home, you should see in plugins, you should see that I have applied directory with this plugin definition, and this is how I am adding this feature. So cluster is still deploying because it takes roughly 2 minutes to be started, and we can check how looks the status, and all is almost started. So it's really roughly 3 minutes. We can check AWS. AWS already running, so we're waiting for TweetPub until he connects to Kafka and is able to send the streams to the Kafka. Before it happens, let me just show you that under this link you can really read more about the plugin, how it's done, how it works, and with all this example what I'm showing here in this video. So check it out and let us know what do you think. And we should have everything running, and here finish our Helm apply Twitter stats, and you can see that in the end I have just link with the IP address where is running my UI on external address. So if we check it here, we can see that it's very small, but real time we are collecting tweets through all this analytics text and displaying. You can see that new hashtags are appearing, so it's showing like most popular hashtag. Last thing what I want to show is that because we're using native Helm and extending Helm, you can use standard commands like diff or dry run to see the differences and dry run. So you have all native Helm features, and so it's not nothing which is like customized or highly. It really using the similar things, and you can see here example, right, that during dry run it's trying to modify the IP address for Tweet API, which is public one, and it's not defined during dry run, because the way how it works is that it applies the charts, reads the output file, parse the arguments, and dynamically on the fly generates the overrides. So this is the demo what I wanted to show today. Maybe last thing is that we will work on extension of this plugin, and we plan to add some other features which could help for intelligent workload policies, because if we can define cluster, it's just beginning. We can also define the rules and the way how workload can be placed, but this probably in the future. So thank you, thanks for watching.